Good morning. Here, today's topic is this one, that is gravitational potential. Okay. This topic you will find in the chapter of Newton's law of gravitation. Okay. There you will find this topic. So let us start this topic. Okay. First we need to know how gravitational potential is defined. Say there is a gravitational field. Where you will find gravitational field? Whenever you will find an object, so surrounding that object, of course there is gravitational field. Gravitational field must be present over any object. If the mass of the object is small, then intensity of the gravitational field will be weak. And if mass of the object is large, it is high, okay, then in that case, the surrounding that object, the gravitational field will be stronger. And as one more thing, gravitational field, if you go away from that object, then gravitational field will go on, the intensity of the gravitational field will go on decreasing as you go away or move away from that object. Okay, so here we are talking about gravitational potential. We know that when in the case of free falling of a body under gravity, the velocity of the body increases with time. Okay, and since velocity increases, and we know that half into mass into square of the velocity is equal to kinetic energy. So since velocity increases, therefore kinetic energy also increases. So with time there is a change in kinetic energy and it goes on increasing when a body falls toward earth. Am I right? So since it is gaining, the body which is falling under the pull of gravity, it is gaining kinetic energy. So it is gaining with it work to be done by the body. Since it is gaining kinetic energy, so now it is able to do some useful work. Am I right? Yes, this is known to you. So here, work is not done by the body, but work is done on the body. Am I right? And that work is stored in the body, and that stored energy can be used to do some useful work. So here, work is not done by the body. We know in physics the convention is when work is done by the body, then work is taken to be positive. And if work is done on the body, in that case, work is said to be negative. Work done is said to be negative. Am I right? So, when a body falls freely under the pull of gravity or under the action of gravity, in that case, the potential energy of the body will be negative. Anyway, now let us come to this point, gravitational potential, how it is defined. Say if we talk about Earth, so what we have already mentioned that as you go away from Earth, the intensity of the gravitational field will go on decreasing. Okay, so but mathematically you will not get somewhere the gravitational field to be zero. Yes, if you put gravitational field is equal to zero, intensity of the gravitational field is equal to zero, then you will get that distance to be infinity. So at an infinite distance from the object, here object of discussion is our planet Earth. Okay, and this thing will be applicable for any planet or any other object. Okay, Just for example, I am talking about only Earth. So so conclusion is what? At an infinite distance, means at infinity, the gravitational field is zero. So it is arbitrarily chosen that at that distance, means at infinity, the potential energy of any body is zero. Okay? Potential energy of any body is zero at an infinite distance. At an infinite distance from what? From that object of which you are going to calculate gravitational potential. Now, from that infinity, when a body is brought to the gravitational field of the object of discussion, means here in this case our planet Earth, then the work done on that object in bringing the body from infinity to the point in the gravitational field is called gravitational potential of that body. So gravitational potential is nothing but work done, and it depends upon both the mass of the planet Earth and the mass of that object, because this is work done. Why planet Earth is coming into picture? Why? Because depending upon the mass of the Earth, it will exert gravitational pull on that small object. If mass is large, then it will exert large force on that small object. If mass of the Earth is small or the mass of the planet is small, then it will exert or apply small force on that object. So the work done or the gravitational potential depends upon the mass of Earth as well as mass of that body, because that small body, if it is of large mass, then more work needs to be done on that body. Am I right? If it is having small mass, then less work needs to be done on the body in bringing the body from infinity to this point of discussion. So we can say that since gravitational intensity of gravitational field is different at different points of the large object, that means gravitational potential also will be different at different points of the large object. Here large object is planet. Many times I have mentioned the same thing, that large object is here planet, but the same theory you can apply for anything, any object. Okay? So let us assume that planet of Earth is capital M, small m is the mass of that small object, capital M and small m. Okay? And from the theory of potential energy, we know that change in potential energy, now I am writing here, change in potential energy denoted by delta U, capital U. Okay? This is equal to U suffix B minus U suffix A. Means a body was at location A, and means initial location was A, final location was B. So the body was taken from A to B by the application of some force. So what will be the change in potential energy? That is equal to potential energy at the final point minus potential energy at the initial point. Here B is the final point, A is the initial point. So this is the difference and this is the potential energy, change in potential energy, and this is equal to negative of work done. I'll discuss this thing in another video, okay? That is equal to negative work done. W suffix AB, first you write A then B because the body is taken from A to B. So that way work done is written. Initial point, then final point. In between A and B, you can put one hyphen also. Okay, so minus WAB, and this is equal to what? This is equal to, there is one expression that this is equal to capital G. Capital G is nothing but universal gravitational constant, that is known to you, into capital M. Here capital M is the mass of our planet Earth. Small m is what? Small m is the mass of the small object. Okay, into something. The last part is visible or not? Yeah, that is visible. There is no problem. Here you will get 1 by radius. But the radii are different. It is 1 by r, this is also 1 by r, but they are not same. Somewhere it will be b, somewhere it will be a. Here r represents distance of small object m from the large object capital M. Okay, r represents distance of the small object m from the large object capital M. Okay, so that is the distance. And this is equal to what? 1 by, here r, here is also r. So this is equal to 1 by r a, this is a, and this is b. Okay. This marker pen is creating problem. Okay. Ink is there, still it is. Anyway, this is RA, this is RB. Okay. 1 by RA minus 1 by RB. So, using this formula, we can calculate gravitational potential at a given point. Okay. So, at infinity, what is the potential energy? At infinity, the potential energy. Okay. You write this way. U within bracket infinity. At infinity, potential energy is 0. Okay. You write this way. So, at infinity, potential energy is 0. Suppose the point B is at infinity and point A is in the gravitational field of Earth. Right? So, we can write, using this formula, we can write U infinity minus U R. Here R represents distance from planet Earth. Means from the center of the Earth. Okay? The distance will be measured from the center of the Earth, not from the surface of the Earth. Okay, so U infinity minus UR, so this is equal to what? So U infinity minus UR, you have to use this formula. So you write G capital M small m, and here within bracket you have to write this thing. Here in the numerator 1 will be there, and in the denominator what will be there? It is, here it will be R. Okay. Here it will be R, means potential energy at location R. So RA will be replaced by R, and this RB, this is what? This distance is infinity. So in the denominator infinity will be there. So 1 by infinity is nothing but 0. And here minus UR is there, and U infinity is 0. Therefore what we are getting? UR, this is equal to minus GMM by R. So what we have got? We have got that gravitational potential at a given location, at a given point is equal to negative. Because here everything is positive. G, capital M, small r, all are positive, and there is one negative sign. So gravitational potential at any location is a negative quantity. And I have already explained the reason behind this, why it is negative. Because work is done on the body in bringing the body from infinity to the gravitational field at that point. Okay. So this was all about gravitational potential. The chapter was Newton's law of gravitation or only gravitation. Okay. So this is very important. Anyway, if you still have any problem, you can write easily in the comment box of this video. Okay, I'll try to answer to your queries. Anyway, this is the end of this lecture. Thank you for watching this video.